Good morning, guys. We are going to be working on problem AMI problem um, for day 13, which is the one that you see at the bottom of my screen. So what I've done to help you out is I have just changed the numbers in the expression that you see at the top. And we're going to look at how to find equivalent expressions for 0.5 t minus 14. And we'll talk about how we know they're equivalent and so forth. Okay, so one final edit I want to make here is right here and make that 5t, and then over here the 21 needs to become 14. Okay, all right, so let's go ahead and start. So you guys have 4 answer choices to choose from, and you can see them down at the very bottom of my screen. And I need to change to pen mode to get started here. Okay, so I notice there's a problem. This should be 3/4, and I think I need to edit that too. Okay, so give me a moment here, and what I'm going to do is edit that. That should say 3/4 times t minus 21. 3/4 parentheses t, whoops, parentheses t, did it again. There we go. And then same thing over here. We need to fix this one. That also should be 3/4, and then in parentheses. That's fine. Okay. Whoa. One sec, guys. There we go. Okay, so let's look at how we can find some equivalent expressions. So one thing you guys need to observe about the expression 0.5 times t minus 14 is that 0.5 can be written in fraction form, and you guys know that 0.5 is a half. 0.5 is also 50%, equivalent to 50%. So another way we can write this expression is 1/2 times t minus 14. Okay, and we know that these are equivalent because 1/2 is equal to 0.5. Okay, and let's look at the second option that they give you down here, where you have to use the distributive property. So I'll go ahead and write that down. Distributive property. Okay, same thing over here as well. Okay, so an equivalent way of writing 0.5 t minus 14 using the distributive property would be like this. You all know now that 0.5 is equal to a half, And now in the parentheses, we need to put a t, since a half will be multiplied with t, our minus sign, and then half of what number equals 14? Well, I know that half of 28 equals 14. So when you guys distribute the half, in other words, you would do a half times negative 28, you get negative 14. Okay, so if we distribute, you get a half times t, and then I'll write it off to the side here in a different color. A half times negative 28 equals negative 14. Negative 14. There you go. All right, let's keep going here. So if we look at the third option, it says 0.75 times t, and also times negative 28. Okay. Well, that's the distributive property, but instead of a fraction, they're using the decimal version of a half. Okay. So if our expression looked like this, 0.5 times, in parentheses, t minus or 28, or you could say t and then negative 28, you would distribute the 0.5 to the t and to the negative 28. So this would equal 0.5 t minus, that's minus there, or negative. And then what's half of 28? We know that from the other problem. There you go. Distributive property. All right. And let's look at this last version here. You have this fourth option that you have to check to see if it's equivalent to the expression in AMI problem 13. So I'll give you a sec here to catch up. You should be writing this down. And let's erase the first one we did. Erase the second one. And I'm going to try to move this last one I did with you guys. There. Move that off to the side. And let's go for the last one here. Okay, so in the problem, it'll say t minus 0.25 times t minus 21, okay? Well, what you have to understand about this expression, this lonely t here that starts the expression has no coefficient, has no number out in front of it. Well, that's because it's a 1. It's a 1t. 1t minus 0.25t. Well, if we do some combining like terms, we can simplify it and see if it's equivalent. Okay. All right, so let's create a similar expression for the example we've been working on right here. Okay. So if we have an expression that looks like this, t minus 0.5 times t minus 14. Let's combine like terms here. We've got this guy and we've got this guy here. Now remember, there is a 1 in front of this t. That's just how it is in algebra. If there's ever a 1 in front of a variable, they're not going to write it in. Okay, so 1 minus 0.5. What is 1 minus 0.5? What's 1 minus a half? A half. So you guys may be thinking this looks like Khan Academy, doesn't it? Okay, so when you combine those two terms, 1t minus 0.5t, you're left with 0.5t minus 14. So that's equal to our original expression. That's how you would check that choice. Okay. All right. Now let's clear everything we've done so far. And we'll do one more practice expression. What I'm going to do, guys, is get rid of the first one we worked on. This one. And move this one up, but I just want to move up part of it. So let me see if I can get this to work. I want to move up the text only. So I want to copy the text. Yeah, there we go. Copy that. And then use another text box at the top. Paste it there. Explain how you know for each. Okay, so we're good. Switch back to the pen. And now we have an expression that says, or we have a problem that says, decide whether each expression is equivalent to 0.80 times t minus 20. Explain how you know for each. Okay. So we're going to refer back to the 4 choices that you guys have in AMI problem day 13, like we did for the first one. And we're going to start right here. Okay, so it gives us an expression. We need to check if it's equivalent to 0.80 t minus 20. But we're going to obviously change it since we know this one's not equivalent to the example I just made up. So what we need to look at is the fraction version of 0.80. So that would be 80 over 100, but we want to simplify that a little bit down to 8/10. So and we can simplify that down even further to 4/5. So if you guys see any of these fractions, they are equal to 0.80. Okay, so let's use 8/10 times t minus 20. That is equal to 0.80 t minus 20. And I showed you here, any of these three fractions are equal to 0.80. Okay, that's how we can justify that. You'll have to fill in the written justification here, explain how you know for each. Okay, let's move on to, I want to skip over this one. Let's move on to the third choice. And if you guys remember, this one deals with a special property. It's important for you guys. It's called distributive property. So is this one? No, this one over here is also distributive property. All right. So we're going to move on to the third choice, which will force us to look at an equivalent version of this expression where we need distributive property. All right, so I'm going to switch colors really quickly just so we can distinguish it from the first work that we did, the first expression that we checked. Okay. So in distributive mode, distributive property form, we would have 0.80 on the outside of the parentheses. On the inside, we'd have the t. So when we distribute the 0.80, we end up with 0.80 times t. And then you guys notice the minus sign or negative. Okay. Now, 80% of what number equals 20? We'll have to think about that for a sec. 80% or 4/5, whatever. I want to say 100. So what do you guys think there? 80% of 100. Does that sound right? No. So just a quick aside here. We could do 80% of a number that we don't know equals 20. Well, that's a one-step equation. We can solve it by dividing 20 by 0.80. And I'm going to pull out a calculator here. And check this. Okay, so 20 divided by 0.80 equals 25. So 80% of 25 equals 20. So when you distribute the 0.80, you would get, you would have to work out 0.80 times 25, and that equals 20. So that is equivalent to our expression for example 2. All right, now let's look at the last example, and we are done working this one out. Get rid of that. This. Okay. See if I can gather up. Well, I'm not going to be able to gather it all up. Okay. Until I get rid of this. Okay. Let's put that aside. And let's work out the last choice here. Okay. So and speaking of which, let's change colors as well. Change to magenta. Okay. So if we have an expression like this, t minus 0.20 t minus 20, we're going to have to combine like terms again, like we did for example 1, to simplify this expression and see if it's equivalent. You may be able to see it or do it in your head using mental math. But remember, whenever you have a variable like this one, t, with no number in front of it, you can automatically assume it's a 1, okay? So 1 t minus 0.20 t, well, we have to combine like terms there, and if you subtract 0.20 from 1, you get 0.80 times t minus 20, and that's equivalent to our second example up here.